So, one of the main reasons that I decided to study at TU Delft was the fact that they have such a big emphasis on physical, like lab work, hands-on experience, that sort of thing. They have so many resources and facilities here that I can use, and it's wonderful. You wouldn't get anywhere near this amount of assistance or resources back in any of the universities in Ireland, or even comparatively Cambridge or Oxford or anything. Aerospace engineering requires a lot of big facilities, and TU Delft has that, and they are very enthusiastic about project work and, making you do things that are applicable to the real world. Last semester I was working on a design project where we had to come up with a mission to space, and this semester what they've done is they've divided everyone into their own unique group, so everyone's doing something new. And within these groups, you're doing science, not engineering. You're not so much designing something, but you're doing a big focus on data analysis and trying to conclude something with reason from this data. The stuff that I'm doing at the moment is particularly niche, if I must say so. So I thought I'd explain it to you at the moment and explain exactly what I'm doing at the moment and why it's causing me so many nightmares. To begin with, I should probably explain some fundamental aerodynamics. An airfoil is the shape that a wing is, and a wing travels through air, and you can look at it with any sort of reference point. You could either look at it from the air's point of view, or you can look at it from the wing's point of view. For most of our calculations and modeling, we do it from the wing's point of view because ultimately we're going to be modeling the vehicle traveling, and we want to see how the vehicle interacts with the world around it. We don't want to see the world interacting with the vehicle. So when it comes to a wing, we have something called a boundary layer. Now, a boundary layer happens on anything. A boundary layer is this region of air around an object moving through the air where the air kind of gets stuck, like there is a friction force as the object moves through the air. That means that the air moves slower over it. And because air is a fluid, that means that the velocity of the air relative to the object changes as you travel away from the surface of the object, depending on geometry and airspeed and viscosity and so on. This boundary layer is of a different thickness. The stuff that I'm studying in this data analysis is the disturbances or the particular phenomena that occur within a boundary layer over a swept wing. I actually have a model aircraft here, so this is an A380, and you can see that the wings taper down a bit towards the edges. That's the wing sweep. What I'm studying is something called crossflow. And crossflow is where the air kind of travels away from the airplane's body across the wing. Crossflow. So instead of traveling, just straight down across the wing, it travels outwards. Why? Well, it's because of the nature of how an airfoil works. An airfoil is of a particular shape. I'm not going to go into too much detail, but essentially there is a point across the airfoil where there is peak suction. The suction being the thing that keeps the aircraft in the air. It lifts it, hence causing lift. We're great at naming things in engineering. This point of low pressure, this point of suction, it pulls air towards it in the same way that it pulls the aircraft upwards. And this point of maximum suction is different as you travel along the wing because it's not always the same. As air travels across the wing, it'll be pulled towards the nearest point of lowest pressure, and that won't always be directly in front of it. It'll get pulled a little to the side. And remember the boundary layer? Within that boundary layer, the air loses velocity as it travels closer to the wing. And so when you don't have that source of momentum, the forces that the air feels are not parallel to the aircraft body, but rather perpendicular to it towards the point of minimum suction. So the stuff that I'm studying at the moment is these phenomena, this crossflow. And crossflow, because it's, irregular, it can cause turbulence, and we don't want turbulence over a wing. We want it to be nice and laminar to cause minimum drag and so forth. So what we're looking at is seeing how these instabilities in this turbulence forms, because it's not really been studied in detail so far. And at the moment, what I'm trying to do is run a Fourier analysis with power spectral density stuff, and it's proving to be a nightmare because, like, I keep expecting one result, but then I get a different result, and it's just not making any fucking sense to me because I can get a result that makes logical sense, but I can't mathematically justify any of the steps required to get there. But if I follow a logical order of maths, it doesn't make sense. And now this would be something that I could like work through manually, like by hand. I could double check my mathematics. However, I'm dealing with stuff on the order of like gigabytes of numbers. We're talking literally billions of data points, and I can't check that. So fuck, man, I don't know what to do. It's like fucking 2 o'clock in the morning and I'm still fucking stressed about this. I don't know. Tell me how this went. What's the total outcome of this? Like, I have to finish this report, this analysis by like May. So obviously this sort of stuff is not finished yet. I'm still struggling. I'm hoping that I get this done because, you know, this sort of stuff hasn't been properly studied in great detail. But I don't know, hoping it works out okay. Anyway, Future Alan, I will see you tomorrow.